Hi everyone, I keep making buggy from GTA 5. This series will start with installation of the engine assembly along with the gearbox from the donor car. A standard engine rating is 40 horsepower, but the actual one is unknown, since the cylinders and the engine pistons are most likely worn out and its working efficiency is unknown. While purchasing, we only managed to spin the starter and check the spark, which means that the engine should start at the 90% credible level. I decided to push the engine from below. For this purpose I sawed off two pipes. After installing the engine, I'll return them back to their place. They'll be attached to the frame with the flanges. The first engine fitting was successful. The only thing, when the engine rises, the gearbox can interfere with the angle bar on the frame. It's all clear with the drive gears. They need to be extended from about 10 or 15 centimeters. Now the engine needs to be lifted with a winch and we should find out its exact location in the frame. The main thing here is that the engine should stay in a relative horizon, that means parallel to the floor level, and the drive gear stroke coincides with the suspension travel. The bracket of the gearbox laid down precisely on the angle bar. In this position it'll remain. The distance between the pulley and the frame was about 2 centimeters, which is quite enough. Now the engine needs to be fixed in this position. For this purpose I'll use the original engine mounts. I screwed the slabs to each bracket of the mounts and connected them to the frame using pipes. The engine is in its place and can be detached from the winch. The rear part got loaded and the suspension started working. I decided to weld the gearbox bracket to the angle bar. In order to remove the gearbox, we'll need to unscrew only the mount. Next, I want to install the gear lever. I'll put a native gate with a handle right from this gearbox. This unit will stay high enough. The main thing is that the traction cannot touch the elbow. The rubber traction damper got broken down with time and I welded two parts together. I'll also shorten the shift rod. While tests, it turned out that the gears turn on clearly and the traction doesn't touch my hand. Further go the drive shafts. I sawed the driving bar somewhere in the middle and bolted the flange to the CV joint. Now we can measure how much we need to lengthen the drive shaft. The main thing is that it has free travel, otherwise, during the suspension travel the drive shaft will abut on the differential and damage the gearbox. In order to align the drive bar, after extension, I welded two crossbeams to the workbench. I welded everything and also strengthened the joint with inserts from the pipe. After the bar cooled down, I put the drive shaft in its place. These details occupy this position in the lowermost suspension position. The drive travel in the gearbox is affected not only by the suspension travel, but also the engine motion on the mounts. All these moments should be foreseen before extending the drive shaft. The drive shafts are in place, we can move on to the clutch. The clutch in this case is hydraulic. The cylinders are in place. It remains to join them together and remove all the air from the brake pipes. The working cylinder had to be cleaned, as the bleed screw got clogged with oxidation. After bleeding the clutch, we need to connect the gas pedal to the carburetor. For this purpose I got a long throttle cable from a snowmobile. The tube guide cable was shortened in place. The cable fixture to the gas pedal was rotated 180 degrees, in order for the cable to be not under my feet and also not get clogged with dirt. By the way, in this position it's convenient to weld a tube guide cable mount to the frame. The gas tank will consist of 2 cylinders with a pre-filled Freon. I sawed off the covers from the cylinders and welded them together. I welded a hose barb from below and a filler neck from above. The tank will stay on 2 pipes tightened with 2 clamps. I connected the gas tank to the gas pump using a hose and fixed the fuel filter. I decided to install the battery at the front, since all the weight is already placed at the back. The positive wire goes directly to the starter and the common terminal goes through the frame. Just in case, I additionally connected the engine with the frame using a wire, as the engine mounts play role of an insulator. It remains to connect the electronics and the ignition lock. The carburetor subsystem has quite simple ignition system, so this was easy to do. Now we can dope gasoline and try to start the engine. The engine started safely, but only after I cleaned the carburetor and changed the spark plugs. I realized that I mixed up the stranglers and the throttle plate and put the cable right. Now we can try to drive along the workshop, check the operation of the pedal box and the drives. According to this test, it's already clear that the buggy can move on its own. The only downside is that the piston block has significant wear. A smoke comes from the breather, although there's no gray smoke coming from the muffler during the throttling. There is also a deafening sound under the left valve cover. I hope nothing serious. Now I'm gonna fix it. I took off the valve cover and saw the next picture. One of the rocker arms dangles badly on the bar. It even broke a hole in the cylinder head with a valve spring. I decided to check how it should be and took off the right valve cover. Everything's all right here. The rocker arm's movement along the bar is limited by a bronze plug. The plug on the left side is placed differently. At first I thought that it had moved out of its place during work, but after I unscrewed the bar's attachment nut, I realized that the previous owner just forgot to put the plug in its place during the installation. The valve gap on this rocker arm is almost 1 millimeter. You can't drive like that. The plug should be returned to its place. Further, I set the valves and started the engine. The sound was gone. One less problem. I measured compression one more time. There were 6 atmospheres in all the cylinders. Of course that's not enough, but I think that'll do for the season. There is no oil filter in this engine but an oil centrifuge instead. The cleaning occurs under the influence of centrifugal force. The suspension of heavy particles in the oil subsides on the pulley wall. It seems like the engine consumed much oil and it wasn't replaced for a long time. Chances are the oil was constantly added or was simply changed without cleaning the centrifuge itself. The oil viscosity was chosen according to the recommendations of the manufacturer, but due to such it'd be better to pour a thicker one. Let it be like flushing oil. I'll definitely change it afterwards. After the tests, I noticed that the battery wasn't charging. The native voltage regulator burned out, so I put a more modern relay. The rest of the electronics was left as it was. I noticed that the spark plugs were filled with fuel and it was problematic to start the engine. I examined the carburetor and saw that a large amount of fuel was coming from under the spray nozzle. It wasn't the copper puck. Somehow there was a chip spot under the nozzle where the fuel came from. I got out of the situation by installing a gasoline-resistant ring as a seal. I also adjusted level of the float chamber. I'm done with the engine. Now we can continue assembling the buggy. I welded one more pipe between the engine mounts. This pipe is gonna be used for rear struts connection. I returned the lower pipes of the frame to their place through the flanges. I made a bottom from a thin metal sheet and welded it to the frame on the weld spots. Then installed a second chair. The dashboard will simply consist of 2 oil pressure bulbs and a battery power display. I'm gonna make the roof from canvas like in the original version. The headlights were found of the exact size. Such headlights are usually used on tractors. They are turned on with an old-school toggle switch and relay. I also installed an air filter on the carburetor through the adapter and put a choke handle. I also decided to weigh the buggy. It turned out 480 kilograms with a full gas tank. Still, after riding around the workshop, I realized that it was necessary to remake the negative Ackerman angle into a positive one, otherwise there would be problems while wheels turning. For this purpose I re-welded the steering arms into this position. That's all for now. Budget buggy from GTA 5 is ready and we can finally test it. I wasn't sure about the torsion bars and the steering in general, but this scheme turned out also viable. As many others including me, I had doubts about the engine, larger wheels, and traction. I can proudly say even with its current where it is above and beyond. Do not forget about the fact that we have a super budget buggy that brings so much fun. Our buggy turned out to be almost an exact copy of the 3D game model. And I am convinced once again that a bit of skills, welding, spare parts make it possible to turn the 3D game model into real life. Next episodes will be dedicated to tuning and transfiguration of this buggy into a more serious model. In the meantime, thanks all of you for your attention. Put your thumb up. See you in the next video.